Hello, assalamu alaikum. Hello, hello, can you hear me? Hello, hello.
Hello.
Okay, so can you hear me?
Yes, yes.
So, how are you?
Fine, thank you. Congratulations.
Okay, thank you. So, okay, thank you.
I ask Allah to fill
Okay, pray
your
for
home
us.
with goodness and blessings.
Yeah, thank you. Okay, so let's go our today's class. Okay, so I simply share my screen.
Okay.
Okay, so now can you see my screen?
Yes.
Okay. Okay, so yesterday you also sent me a code. You did not find out the any images for the region of Medina. Okay,
Yes.
so okay,
Yes.
so in this time, if
This is
possible,
the
yeah,
first problem. I have another problem
yeah.
that I sent you from the last week.
Okay, so
So I have two problems.
first of all, I will try to discuss about your problem. So if possible, you can share your screen. Then I also show your code. Then we also continue our today's class. Okay, so you can simply share your screen.
My screen.
Yeah, so you can simply share your skin, your own skin.
But I don't open my Google code.
Okay, no problem. Okay, so we will start our today's class. Then we also try to discuss later about the problem. Okay.
No, I can.
And if
I
possible,
have some.
okay, if
I
possible,
have
yeah. Okay, share
can
your skin.
you
Okay. Okay, so can you share, please?
1 minute. Um, it appear you have to close your screen firstly. I think.
Okay, so I also stopping my sharing skin. So now you can try.
Okay. Are you see?
Yeah, so now it's okay. Yeah, so now skin is
I
sharing. Yeah.
I open
Okay.
your recorded video. Are you see?
Yeah, now I see your skin, but yeah, your skin is okay. So okay, so if possible, yeah, you can run this code in your own system. You can run this code.
Sorry, your voice is very far.
Okay, so you can run this code in your system.
I don't open systems now.
Okay.
I
Okay.
need to know from where and
Okay, so
how
okay, I
this.
understand here. Also, basically, it's called the scaled NDVI. When you want to make
Yes.
the normalized difference vegetation index or NDVI, this NDVI value, this range between the -1 to +1. Okay, -1 to +1. So in this time, you can check. I also share my screen, then try to discuss about this. Just a minute. So then it's also better
Yes.
for you to understand.
I stopped my screen, my sharing.
Yeah. So basically NDVI. So NDVI, it's called the normalized difference vegetation index. So mainly we are using the NDVI for identify the vegetation on the earth surface. Okay. And this index value, this range is that -1 to +1. But you can see when we are working with modis NDVI. So I simply open this previous code. So I simply open this previous code from here. So just a minute. Then it also better understand. So I simply open our previous code. Then we can easily find out the problem. Yeah, okay, so I think just a minute. So I think this code is that. Okay, so I simply open this code in my browser. Not this, not that. No. So I simply copy it. I simply copy. I want to open this code in the Chrome browser. So I simply copy this code and open in the Chrome. Okay. So now it's opening.
Please, are you recording this video?
Yeah.
Okay. Just remembering.
Okay, so this is another code. It's not code. Just a minute. So this is the NDWI. So you need to find out the modis NDVI code. Just a minute. So now I check this code. Okay, so it's also my so just a minute. Okay, just a minute. I write the code again. Just a minute. I open a new code. I and explain the code again so that you can understand. So I simply open a blank code editor of Earth Engine JavaScript API. So in this time, I want to create the NDVI using the modis satellite imagery. So first of all, I need to find out the modis satellite imagery. I simply go to the browse data catalog because when you want from this link, you can get all of the data sets of Earth Engine dataset, modis, Landsat, Sentinel, all of the satellite imagery we can easily get from here. So I simply click on the modis. I want to work with the modis dataset. I simply click on the modis. So now I can simply go to the modis satellite imagery. Here you can see so all of the dataset. I want to work with the modis NDVI. So I want to work with the modis data vegetation index is 16 global, 250 meter resolution. I want to work with this dataset. I simply click here. So now you can see I can get all of the information about this dataset. You can see all of the things I get in here. Okay. So in this time, I want to work with this dataset. So I need to import the dataset in my code editor. I simply copy this code editor from here. I simply copy and then paste here. Okay. I simply paste here.
Yes.
After this, I simply take a variable name. So I simply take a variable name is that suppose modis. You can put any name, no problem. And then I also need to import the shapefile, country boundary shapefile or your region of interest. So suppose in this time I want to work with this region for Mombasa. So this is the one kind of Mombasa. I simply import this shapefile variable as a table. I change it. I put the name is that RY. Okay. So in this time, I simply show the result of this my RY. You can see I add a layer, map.add layer, and then I simply call this ROI. Okay, so this is my shapefile variable name, and I also need to focus the center object. So map dot center object, and I simply put here the ROI, and then this is my region. I select my region. You can see. So this is my region. For this region, I want to make the NDVI map using the MODIS satellite imagery. Okay, so let's go. I simply select the MODIS satellite imagery, and then I simply take a variable. Suppose I put the variable name is the MODIS NDVI. Okay, and then I simply call this full image collection. You can see the full image collection is stored in a variable. This variable name is the MODIS. I simply copy and paste here. Okay, I need to simply use I need to select. I want to select the band. Okay, in this time you can see this dataset has a two band. First band is the NDVI, second one is the EVI, and I already discussed about that. What is NDVI and what is EVI? Okay, I want to work with the NDVI. Yes. I simply copy the NDVI band and then I simply paste here. Okay, so now you can see I want to check how many images are available for the whole world from the MODIS dataset. I want to check it. So I simply use the print function and then I simply call this variable name. Okay, so I simply copy the variable name and paste here and use here the size function. Okay, and click to the run. So now you can see our console tab will be open. It computing. I can find out the total 521 images for the whole world for the NDVI. Okay, so in this time I want to need for the any specific time period NDVI images, not for the whole time period. You can see from this satellite image you can get the dataset from the year of 2000 to 2022. This time period I don't need a big deal time period. I need only for the any specific time period such as 2015 to 2020, or only for the 2000, only for the 2021 or 17, anything, any time period you want to select. So and for this I simply take a variable. I simply take a variable, suppose filter NDVI. You can put any name, no problem. And then I simply call. You can see these 520 images are stored in a variable. This variable name is that MODIS. I simply call the MODIS. Simply copy and paste here. And then I need to use a function. It's called the filter. It's called. I simply use the filter. Sorry, it is the lowercase. So filter date. You can see what is the argument start date and end date. I simply put it. Suppose I need observation of the NDVI for year of 2021. I simply put the time period 2021 1st January from. I simply put here the 2021 December 31. So I simply select the time period and then I need to check how many images are available between the year of 2021. I simply use the print function and then I simply call the filter NDVI. Simply copy and paste and use the size function and click to the run. So now you can see how many images I want to get for the year of 2021. I can get only for the 23 images. Okay, and this 23 images, what is the time interval? This time interval is that 16 day. Okay, if you want to check the time interval, simply you can simply print and then I simply call the filter NDVI, click to the run. In this time you can see what is the time interval for the 23 images. Here you can see all of the time interval. You can see from the property, from the feature. See first image you can see year of 2021 1st January, then 17 January, then 2nd February, 18 February. So I can get all of the images from the first image to last second image. We can get the interval is the 16 day. From the second image to third image you can see 16 day. So all of the images we can get the what is the time interval? Time interval is the 16 day. So that's why this dataset called the 16 day global 250 resolution. Okay. So in this time I need to reduce this image collection. Okay, so there is a lot of process for reducing. Suppose in this time you can see this image is not created at the same time of the year. This image is created the different time of the year. Okay, so that's why I need to reduce this image collection. Okay, so that's why I simply call a variable. I simply take a variable and give the variable name is the suppose mean NDVI. You can put any name, no problem. In this time I simply call this filter NDVI and paste here and use here the reduce function. Reduce. how I can reduce? I want to reduce using the average. Suppose I want to create the average pixel value, all of the images. Okay, I want to use here the EE dot reducer dot mean. Okay, so now it's created the mean result. Okay, I simply show the result, map dot add layer, and then I simply call the mean NDVI. Simply copy and paste here. So now I simply click the run. You can see I can get the whole world NDVI map. Okay, because I did not, you can see first time I can get the result look like this. Okay, as the ash color. Okay, so as the ash color I did get the result because I did not add any visualization. So in this time I want to add here the proper visualization for showing the better result of the NDVI. So you can see I simply go to here and then I simply copy this visualization code from their previous code. I simply copy this code and then paste here. I simply paste here. And we already know about that. After the object name, you have to paste here your visualization variable name. Simply copy and then paste after the object name. Okay. Now you can see we can easily find out all of the dense vegetation, lower vegetation, desert area for the whole world. So you can see. So you can see now I can get the whole world NDVI map. Okay. So the whole world NDVI map here you can find out. So we can easily identify this is the Amazon. Also you can see this is the desert. Okay, Sahara desert. There is a very less vegetation. Also you can see the Saudi Arabia region. Okay, so there we can easily find out the whole world NDVI map for year of 2021. Okay, so in this time I don't need for the whole world. I need only for my specific region. So this region I already imported my shapefile Mobasa. So this shapefile, this is the Mobasa. This is one kind of the region. So I want to work with this, make this NDVI map for this region. So in this time I need to clip. So I just simply clip, no problem. So you can see I just simply use here the clip function. So now it will be clipping with my shapefile. What's my shapefile variable name? My shapefile variable name is that ROI. You can see ROI. I simply use here the ROI and click to the run. So now you can see I can get the result only for the Mombasa. You can see I can get the result look like this. Okay. So I can get the result look like this. In this time you can see, if you can see, in this time this part is not, there is nothing showing in here because this data set is only for the tra vegetation, not aqua. Okay, so we can get the result only for the tra region, not aqua region. Okay, aqua region means that ocean or other things like this, but you can see this data set is tra vegetation indices. Okay, tra. So this we can only find out the vegetation index for the tra region. So you can see I can get the result, but this map is not proper. This map is not proper because you can check the value for NDVI. Click on the and you can simply check. You can say I can get the result 1312. It's not maintain the sequence of the NDVI range. You can check the what is the NDVI range. NDVI range. We already know about that. NDVI range is the -1 to +1 or +1 to -1. This range I can get the value. This range. Okay. So in this time, anyhow, I need to get the result -1 to +1, -1 to +1. In this time, it's showing this result, but I need the result -1 to +1. This is my main target. So that's why I need to reproject my scale value. And how I can reproject my scale value? So I can simply, you can see this is my information. It's called the dataset information page or dataset information link. Okay, here you can see the band. Okay, you can see for the NDVI they are also provide the scale 0.0001. Okay, 0.0001. In this time I just multiply with my scale all of the images. I want to just multiply 0.0001. Then it's automatically reprojected the value of NDVI, and then I can get the result look like this, +1 to -1. Otherwise it's not apparent. Okay, so in this time my main target is that I need to reproject the scale value. Okay, so here you can see I want to get 23 images. Okay, this filter NDVI I get the 23 images, but this 23 images is not reprojected. That's why I did not get the -1 to +1 result. I did not get. In this time these 23 images I want to need reprojected anyhow. And for this, I need to multiply with this value, scale value. Okay, you can see I get the scale value from in here. Okay, okay. So in this time,
Yes.
I use here the function, because we already know about the function. What is the function? Function is mainly reuse your code and make it easier to read. So let's go. So what is the function formula? You can see I simply take a variable. And put the variable name is the suppose scaled NDVI. You can put any variable name, no problem. I create a function. So I simply use the function keyword. Function, sorry, lowercase. So function keyword. In this time, I need to put a element name. Okay. So in this time, you can see when I use at the A and then use at the B and use at the C, it means that it has 3 element. Okay. When I use only for the A, it means that only for the 1 element. When I use at the image, it means the only for the 1 element. When I use at the image, it means that there are the total 2 element. When I use at the image, it means that it has total 3 element. Okay, you can see here in this time, here I can get total 23 images. Okay, for each images, I need to put single value. Suppose image 1, suppose I put the image 1, then image 2, image 3, image 4, and up to image 23. Okay, it's a very lengthy process. So that's why we are using the function. So in this time, you can see I take only for the 1 element. Okay, so no, I take the only for the 1 element. Suppose image, I take the element for the image. So I simply use the curly bracket, and then in this time I need to what I want to use for the image. My main target is that this image returned the value after multiply with the scale factor. So I simply use the return function, return, and then I simply call the element name image, and it's multiply with the scale factor 0.0001. Okay, so now you can ask me a question. In this time, I take only for the 1 element. It means that it's included only for the 1 image. Okay, but rest of the 22 images, how I can reproject it? Rest of the 22 images, how I can reproject it? So that's why I need to use another function. It's called the copy properties. So I simply use the copy properties. And what is the copy properties? So mainly copy properties, it copy the image metadata from previous. Suppose you can see I simply multiply with this scale factor. Okay, in this time when I use the copy properties, it also copy this image. Okay, and multiply 0.0001 scale factor. I simply use the image because I want to use the image copy properties image, and I need to define here the two things: system time start and system time int. So you can see in this time what I do in here. I want to copy this image properties. Okay, and I want to set the value system time start and system time int. It means that you can see I already define a start time, I already define a int time in here. Okay, so in this time I want to multiply all of the images. Okay, so between this time period, all of the images multiply with this scale factor. Okay, so that's why I simply use the system time and system time int. Okay, in this time here you can see I want to check how many images I want to get after the user the scale. I simply use the print function, and then I simply call the scale NDVI. I simply copy and use the size function. So now you can see I get the same images. Okay, So just a minute. But okay, in this time there the another thing is that I create the function. But my all of the images stored at the scale filter NDVI, this variable. There is the no connection. You can see this is the function and this is the another code. In this time I need to connecting. So I simply copy this variable name and paste here. And when you connect the function with the whole collection means that 23 images. This 23 images is stored in a variable filter NDVI. Okay. So in this time I need to use the map function. Map. Use the parenthesis and also use the parenthesis. Okay, done. In this time I simply check how many images I have to get. You can see I want to get total same images, 23 images I want to get. Okay. In this time I simply copy and use this image in here scale NDVI, because this scale NDVI it stored 23 images and this 23 images is reprojected our scale value. Okay. I simply click to the run. Okay, you can say I can get the totally black color, white color image. Okay, because I also need to change the visualization. I simply put here the -1 to +1. So now you can see in this time. But this is visualization is also not good. Okay, I simply change the visualization. I remove all of the color. I change color. So I want to show the result for the which pixel value is the -1. I want to show the result as a blue color. So blue color, it means the water. Then use the white color after greater than I use that, and I use the green color. So now I can say I can get the result. And from this result, we can easily identify the dense vegetation as well as the low vegetation. We can easily find out. You can see for this region.
Yes.
In this, I simply inspector tab and can check it. You can check I can get the value 0.7. It means that now it reprojected and I can get all of the NDVI value. You can see for the water, I can get the negative result. For the water, I can get the negative result. For the water, I can get the negative result. For the dense vegetation, I can get the high positive result. Okay. So this is the process for reprojected the scale value using the MODIS. Okay. So mainly with this process, we are using for the -1 to +1 because NDVI result, this range is that -1 to +1. Okay. So otherwise it's not work. So MODIS, and suppose you can check the another data set, suppose Landsat NDVI. Landsat NDVI and check this data set. Basically, you can see when I use the Landsat NDVI, this data set is already reprojected. You can see this data set is already reprojected. I can get the result -1 to +1. Okay, this is the range of the NDVI. This data set is already reprojected. When you are using the Landsat NDVI, you don't need to multiply with the scale factor. You can see there in this time they are also not provide the scale factor because it's already reprojected. Okay, so when you use using this data set, you don't need to use here the reprojected your scale value because it's already reprojected. Okay, so if you have any question in this code,
I have to back to the map or catalog that I use to determine if I use the scale function or not.
Yeah.
Hello, where are you?
Okay, so now so in this time I also try to discuss our today's class. So if you have any question or any doubt,
no, I I need to discuss the second problem.
okay, so you can discuss about the second problem. And if possible, you can also share your screen, then it's also better for the showing the result for the second problem.
Mm. 1 minute. I want to show you also your video because my work all was deleted. I want to explain on your video.
Okay. Okay, so we will continue our today's class again. So let's go. Okay.
Yes, 1 minute. Um,
Okay, so basically, today I will try to discuss about the some topic about the land use
no,
and
no, sorry.
yeah,
Sorry. I
yeah.
want to know what is the reason and that appear with me yesterday. Why all maps give me 000?
Okay, so you can send me the link, please. Then I also check the link for the code link, if possible, to send me this link.
I sent them yesterday on WhatsApp to you.
So you can send me the link. Okay, so I also, and what is the region you are using this code? What the region?
The same region that you discussed on Medina.
Okay, so this is the whole Saudi Arabia region or any state?
No, Medina region.
Okay, so I also write the code again. Just a minute. Okay, so I simply
It gave you nearly 25 image, but when I worked on, it give me 0.
okay, okay. I'll check the code again. Just a minute.
I sent you the codes that I worked yesterday.
Saudi Arabia province. I simply import your all of the Saudi Arabia province, and I want to select the state of the Al Madina. So I simply use the ROI, and then I simply call the table, and I want to filter it. I want to filter art engine filter dot equal. I simply call here the column name. So I simply copy and go to the feature. So I simply click on the feature and I simply use here the
Sorry.
name one. Yeah,
Please.
yeah,
I have another question
yeah,
here.
yeah.
On this feature, no, back to features. On features, not all districts or regions in Saudi Arabia appear on this table. Yeah, Mecca doesn't appear.
Okay, okay.
Jeddah
So
doesn't
it's
appear.
it's showing only for the 10. Okay, 10 first 10, but you can get all of the things from the another way. This way is that you can simply use here the print function, print, and then simply print the table and click the run. Just a minute, and print the run. You can see Now it get the all of the feature. We can get all of the name, all of the things you can get. You can see. Go to the feature. So here you can see total 13 state or 13 province. You can get all of the province name. You can see the Asir. You can see the Al-Baba, Al-Bahab. Baha. You can see also
Al-Baha.
you can see the Al-Hudud. Okay, Hudud. Also you can see the Al.
How many?
Yeah.
How many region appear on this?
Also you can
I
see
think it's
Al-Madina. You can
small.
see. Okay.
Mecca.
And also you can see
Mecca doesn't know.
the region Al-Qasim.
Al-Qasim.
Also you can
Only 12? Only 12
Al-Riyadh.
area?
Yeah.
Only 12 area? Region?
Yeah. Also you can see the
الشرقية.
yeah, Hail,
حائل.
Jijan, Makkah. Okay, we can get the Makkah.
مكة.
Simply copy the Makkah or any name you can simply put, and then I simply show the Makkah region. I simply put here the Makkah. Okay, so now I want to show the result.
Yes.
So I simply use here the map dot add layer and use here the ROI, and also need to map dot center object and put here the ROI and 10. Now I can say I can get the Makkah region. You can say I can get the result for the Makkah boundary shape file. Okay.
Yes.
So now you can see, suppose you want to need the result for, you need the satellite images for this region. You can easily get the satellite images. So for this, I simply go to here and click on the browse data catalog. I simply find out the Landsat. I get all of the, I want to work with the Landsat, this image collection. I want to work with the top of atmospheric image collection. I simply copy this, copy and simply paste here, and then simply put a variable name, suppose L8, and then I simply take a variable name, suppose image, and then use here the L8 dot, I simply use here the filter bounds with RY. I want to simply use here the filter date. I simply put here the start date, suppose 2021. Okay, 2021 December 31. I put here the filter metadata, use here the cloud cover, less than 1. I need to check how many images I need to get. Can check, I going to get total 230 images. Okay, for this region. So I want to check how many images for the Modena. Okay, so I'll check the Modena again. Just a minute. So okay, I simply get this name from here. I simply copy Al Madina and I simply post here the Al Madina. Okay, and click to the run. 244. Okay, so now I hope you can got the idea. You hope when you use the same code, I hope you can also get the same number of images. Okay,
Give me 0.
why? I don't understand about that. Why you can get the
I
0?
don't know the reason.
Okay, so I also
Why?
send you this code link, so you also try to for your own self. So there is the no 0 FVR rate, I think. Okay, so you also try to for your own self again, and also try to make the similar code. Then I hope you can easily get this result. Okay, in this
It,
time,
it,
yeah.
it didn't give me any wrong or something
Okay,
like this,
so
but
okay,
it gave me 0. It means is that in this area have
there is a no
no
image. Yeah.
images in this time period.
Okay. So I think you have also some problem or other things for the any. So you can also send me the code link. Suppose in this code you can get a problem. Okay, so simply click the get link button, and then simply you can see, click to here, click to the copy, and then send me this
Mm.
code link. Then I can simply open the code link in my system and check what is the problem. Okay, so when you face any problem regarding this any code or any issue, simply click the get link button and click
Yes.
to copy link
Mm.
and send me this link.
Yes.
Okay, then it also better, I can easily access your
Mm.
code. Okay, so next time
Okay,
when you face any problem,
I will try.
yeah, you can send me the
I
code
will
link
try
look like
that
this.
time.
Yeah, then I simply use the different way. Suppose I want to make the reduce the image collection, get the median image collection. Okay, then it's also we can easily get the lens set images easily. Suppose I just simply use that the suppose median function.
Oh, thank you. Sorry,
Yeah,
I will try them again. But I have another question.
yeah,
Then you can start our session today. The cloud cover.
yeah. Okay,
Cloud cover.
so okay, you also, yeah.
This is from image properties.
Okay,
Yes,
okay. So I use this image
but
for make the
in
land cover, no
sorry,
problem. Yeah,
sorry. I don't finish my question.
yeah.
In this image properties, a lot of properties like cloud cover present. Um, I need to know what does of mean of these properties or how can I use them? Are you understand me?
So
In
if possible, you
image,
can simply text write in the text in the WhatsApp messenger is also better.
I write
Yeah,
message.
write the message. Yeah.
Mm, I think. I think my discussion will be better than written. All you do now, I understand. So my question about the image properties that have a cloud cover.
Yeah,
Cloud cover. Are you hear me?
yeah, I hear you. Yeah,
Cloud cover.
yeah,
You get cloud cover or you copy cloud cover from image properties.
yeah. I can get this as an
Yes,
image properties. Yeah, you can see image
yes,
properties.
yes. In this part, image properties, there are many properties. Cloud cover, land collection, collection data source, and so on. How can I use these properties? Or what
Okay,
does of mean of
okay.
these properties?
The same
That
things.
can I benefit from
Suppose
this?
in this time you can check. I simply check it. Suppose I just simply commenting this line and try to print this code again. You can check. Instead, I want to get the images, all of the information. So feature. Suppose here I can 244 images. Okay, I check the first image. All of the things I take the first image. So you can see the properties. You can see cloud cover 0, cloud land cover 0, collection categories T1, collection number 2, collect data source elevation GLS 2000. Also you can see all of the image properties. You can see data acquired date, you can see 2021 first 21 January, data product generated, datum WGS 84, earth sun distance. So all of the information about this image you can get also in here. Suppose in this time you also need to filter the other properties. Suppose you want to filter the cloud land cover. So simply copy this, simply copy, and also use here the filter metadata.
Instead of cloud cover
Filter?
or
no. Suppose you want to make filter the 2 or more image properties.
or more. Yes,
2 or
yes.
3 or more image properties you need to filter. So you can use here the again filter metadata, and in this time it's the cloud land cover. Then you can simply put the less than, how much value you want to need. So I simply put at the less than, suppose 1. Okay. Then now
So,
it's also filtered the cloud over land. Okay, and get the image, how many images is available for the less than 1 cloud over land. Okay, so you can also get this result. Yes, as well as also you can check the any image properties we can filter easily. Suppose you can see the data acquired date, also you can see the image quality OLI. Okay, suppose you can simply copy this, and I don't know what is the image quality, I simply copy this, and then I will simply I suppose I want to use here the filter.
do you know what is the difference between cloud cover and the cloud cover land?
So okay. So this difference is that you can see they also provide the difference about that. Cloud cover is the percentage cloud cover. This is the percentage of the cloud cover, and the cloud cover land, it is the percentage cloud cover over land. Okay, over land, and it's only for the cloud cover percentage. Suppose it's the cloud cover, it's mainly cloud in the sky. Okay, and this percentage cloud cover over land. Okay, and you can see, suppose you can see collection T1, it means that tier of sense. Okay, collection number of collection. Okay, elevation, data source elevation, it is the indicates the source of the digital elevation model or DEM used in the collection process. Okay,
Collection category, collection number. What is collection? Collection of what? Collection of image?
yeah, collection of evidence. Yeah, there are the
Type,
two types of collection you can see.
sorry.
T1,
Sorry.
T1 and T2.
Cloud-
Yeah.
Cloud cover and the cloud cover overland. What does it mean? In really, cloud is over land.
Yeah.
In each cases,
Yeah.
in all cases, cloud is over land.
mainly you can see cloud cover, it means that the percentage of the cloud cover on the sky. This cloud is the different height, no problem. But some cloud you can find out the low distance over the land. Okay, it's called the cloud cover land. Okay, and cloud is all of the cloud, okay, in the here, but how many distance, it's also identify according to the distance. Okay, so it's difference, there is the no limit distance. Cloud cover, there is the no limit distance, but when you want to work with the cloud cover land, it has a distance. Suppose over land, so it's identify the specific distance of the over land. How many cloud you want to need, look like this process. And cloud cover, it's there is a no limit for the distance.
Okay.
Okay, so we can easily filter the more than 1 or 2 image properties and get the image look very easily. Okay, So in this time, I want to get the image. You can see for the Saudi Arabia image for year of 2021. I create this composite, and you can see this is the Saudi Arabia region. Sorry, this is the Medina region.
Medina.
Suppose in this time I want to create this LULC map for this region. Okay? So there is a lot of process or lot of algorithm for creating this algorithm. If you want, you can use here the supervised. If you want, you can also use the unsupervised classification. So all of the things we can easily get. So in this time I try to discuss about that. So I simply go to this class. So basically when you want to make the land use and land cover classification map, we need to follow the some step. Suppose first of all you need to selecting your ROI. You have to select your region of interest. So in this time, suppose my region of interest is that Al Modena region. Okay, Al Modena region. This is my region of interest. Then choosing and filtering the image collection. You need to choose and filter. This image collection can be suppose this image collection can be Sentinel, or this image collection can be Landsat. Any type of image can be what. So you need to choose and filter the image collection. Third process is the collecting the training point. Okay, so this is the very crucial part. Okay, so this part when you want to mistake anything, you did not get the proper land use land cover classification map. Okay, so this part is very important for collecting the training point. Okay, in this time we are using the supervised machine learning method, so that's why we need to collect the training point. Okay, some feature in this time you can see I already select imported my shapefile. I get the Almodena shapefile. Okay, I get the Almodena shapefile. For this region, I want to make the land use land cover classification map. So for this, I need a satellite image. I use here the Landsat satellite image. In this time, this region, I need to classify it. I need to classify it, the land use land cover map. Okay, for this region. But I did not. I in this time I need to select the some training point. Suppose in this region, you need to select the build up area. You need to select the water body. You need to select the cropland. You need to select the barren land. You need to get the sandy land. Okay, so any types of classes you need to select. You need to get the training point. In this time, this place, for this place, I did not have much idea where the water, where the built up area, where the vegetation. I did not go this place yet, so I did not have the much idea about this place. So in this time, so it's also better for the visualization. So suppose when you want to suppose in this time I stay in the Dhaka city, I can easily find out where the build up area, where the water body, where the barren land, where the vegetation, because I already stay in the Dhaka city and I already know about the all of the place very well. Okay, so in this time when you want to work with the land use land cover classification map, you have also better idea about this place. It must, otherwise you can find out you did not get the proper LULC map. Suppose you want to make the map for the Al Madina, so if you have also good idea about the Medina place, where the build up area can be attacked, where the water body, where the you have to mass idea about this place, where the sandy land. Okay, okay, so in this time you can see I use here the true color band combination. It called the B4, B3 and B2. It's called the true color band combination. True color band combination, it means that what human eye can see. So what human can eye see naturally, what human can eye can see. Okay, so in this time you can see this. So can you guess it what you can see in this place? So you can check this image again. So can you check this place what feature it can be, what feature it can be? It will be sandy land or barren land or other things. What do you think about this place? What do you think about this place? I think it is a sandy land.
Yes.
Yeah. You can also check this place for the satellite images for the better looking. So okay. Okay. So this is sandy land. I think this is sandy land. Yeah.
Yes.
And I think what is this?
It's maybe a mountain.
It's vegetation or other things.
It's maybe mountain.
Yeah, mountain. Yeah. Mountain. Yeah, mountain. This is
Yes.
sandy land. This is the mountain, and it's also mountain. Yeah, as well as okay, and it's also sandy land. I think. Yeah. So it's very crucial part for making this land use land cover classification map. And what's the feature you want to get? Okay. So I think this is also mountain or
Yes.
this is mountain. Yeah.
Yes.
Yeah. Yeah. And before the classification map, you have also decided what's the classes you want to classify it. You want to classify the mountain, you want to classify the barren land, you want to classify the vegetation, you want to classify the build up area. So you need to all before the classification, you also need to all of the classes you need to ready. Okay, then according to the classes you take the training point. Okay, so it's also mountain. Okay. Okay. So okay. Okay. So okay. So in this time here you can see I can only use the only for the one. I can only use for the one band combination. So there are a lot of band combination. So you can simply go to this link. So different band combination you provide you the different types of feature. Suppose I use the band combination for the landscape. Suppose okay. So band combination. Okay. So here you can find out the different types of band combination. So landscape 8 band combination. This satellite images. You can see.
Yes.
Okay. So 432. It's called the natural color. So natural color means that human eyes can see. Suppose in this time you can easily find out human eye. Basically, it's showing the vegetation. It's look like the build up area. Okay. Also, you can see the color infrared 543. So it means that when I use the 543, you can get the result look like this. Here the red identify the better vegetation area. Okay. Red identify the better vegetation. Red identify the better vegetation. You can see. Okay. Then also you can see this another thing is the shortwave infrared. So also you can see the agriculture. Suppose you want to identify the agriculture field in your region. Suppose you want to find out the agriculture field. Then you need to use this band combination 652. Okay, and you can see this band combination is mainly used for the crop monitoring. Okay, and healthy vegetation affairs dark green. Okay, so in this time a lot of is available. Suppose I want to work with the 543, so I simply use here the 5, 4, and 3. So I simply use here the 98% and use here the apply. So now I can get the result. You can see another band combination, and I did not find out the any red pixel value in this place because it's very less vegetation area. You can see it working.
Yes. Mm.
Okay, so it working. Just a minute. Okay, why it's takes a lot of time? Just a minute. I think some networking issue. Okay, then apply. Okay, so I can see I did not open this layer, so that's why it looked like this. Okay, so now you can see I can get the map about this region. So in this time you can see for this region of Al Madina, I did not get very less. You can see. Okay. I can get the some red pixel value. You can see. Okay, I can get the some red pixel value. Okay, so this red. Okay, I think this is the red pixel value. It's identify the some vegetation area. Vegetation. You can see. Okay, this is a vegetation. Okay, you can see vegetation.
Yes.
Yeah. Okay. You can see this is the cropland, I think, or other things. Okay, this is vegetation. So in this time, you can get the training point for the vegetation. Okay, for the classified. So it's very easy. You can simply click on here, add a marker, and then click on this edit related properties. Simply put this. I take this class for the vegetation. Vegetation. Okay. Then use add the image feature collection and put the property name is that you can use any name. I simply put add the class and set the value for the 0 and then use add the OK. You can see now I simply click the vegetation. It look the bold letter. After it getting the bold letter, then I take the vegetation. So I simply take the vegetation. Okay. So you can see when I use the 543, I can easily find out the red pixel value. And this red pixel value, it's identify the vegetation. Okay. It's very easy. You can see. I simply take the some training point for the vegetation. Okay. Okay. So I take the training for the vegetation. Okay. So in this time, I need to find out the another reason. Yeah.
Why you add this sign? It already determined by the color. Why we add this sign?
Okay. Because this color is apparent. Why this color is apparent when I use this band combination? Because 543. This 5 is the near infrared band. This 4 is the red infrared band, and B3 this is the green band. Okay. So when you are using this 3 band combination, it showing the result, the vegetation. It is the some. We can also get the some remote sensing basic or beginners class. We also try to discuss about this part. Some band value, suppose near infrared band value, it reflect the vegetation. Suppose red infrared band value, it observe the vegetation. Okay, so different types of signal. So different types of signal or different types of band, it stored the different types of information. Okay, so suppose in this time I use this 543, this information observes the better vegetation as a red color. Okay, so when I use at the 4 3 2, it's called the true color. So when I use this band combination, it's identify the true color or human eye can see. In this time you can see I did not understand this this place. Where is it? It is the water body or it's the basin? I did not understand. So that's why
Yeah,
I moved the
I
another band
understand.
combination. Five.
I understand the
Yeah.
meaning of bands,
Yeah.
but my question about the sign that you add now, what is the benefit of them? But I understand well these bands, what is of mean.
Okay, I understand. Just a minute.
I ask about the signs that you add now of geometry. What is the benefit?
Okay, so here you can see some band. You can see band 1, band 2, band 3, band 4. This band, it is the coastal or aerosol. This wavelength is that, and resolution is that. Band 2 band, you can see visible red band. This visible red band, mainly this band reflected the vegetation. And near infrared band, it observed the vegetation information.
I know all this I know.
Yeah. Okay. So I understand your thought. You have also need to do some basic things about the why I use the band combination and why I can get the result. This type of question you have. Yeah.
Okay, you can complete. You can complete.
Okay. 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 So here you can see the mainly different types of band combination has give you the different types of information. Okay. So better looking information. When I use this band combination, I can get the satellite image look like this. Okay. So when I use this band combination, this satellite image look like this. Okay. When I use the band combination, this satellite image look like this. Suppose when I use the band combination, then I can easily identify the vegetation, water body, and this color. Okay. You can see there. You can also read this from this link. You also try to read this. Then you can easily find out the different types of band combination for different types of feature on that surface. Okay. Suppose I want to use the 652. Okay, so in this time I can also identify the another thing is that I can also get the some um build up area in this region. You can see. So this type of build up area, build up area, build up area. So I take the another, simply click with the new layer and use here the build up and use the feature collection. Property name is that class, set the value for 0 1. So in this time I simply get the training point for the build up area. So this is the build up area. As a red pixel value, the build up area. Okay, I take the build up area. In this time, I also need to take the another thing is that suppose build up area vegetation and okay, so it has also some build up area. I can see. Okay, okay. So in this time, I simply click to here and take the another area for build up area. I use here the build this combination. Suppose 652. I use the band combination. I use here the 652. Sorry, 652. Mainly we are using this band combination for identify the barren land as well as also cropland or other things. Okay. In this time, this yellow color region is identified as a barren land, okay, or fallow land. So I simply use here the barren land and use here the feature collection. Property name will be class. Set the value for 0 1 2. So 0 1 then 2. So here you can see yellow color. So yellow color you can see it look like a barren color. You can see there is a nothing. You can see in this place there is a nothing. It's showing the as a Hello land. Okay, or we all can also say that this is sandy land. So either take the training point from this. Also you can see I take the training point also from here. Lot of barren land. Sandy land, I think it's also barren land. Like, okay. Okay, I take the barren land. And then I also take the for the water body. It's very difficult to find out the water body in this. Also try to find out the water body. Water body for this I get this color 543 543. Or if you want, you can also use here the identify the water body. You are using here the index NDVI index for identify the water body. So I use here the 5 4 3 5 4 3 water body look like this. Blue color. This combination is the nearby. It's the nearby. Okay, so analyzing red berry vegetation, dark areas, water, and red is white. Dark areas of water. It's water. What do you think about this place? Hello, can you hear me?
Oh, sorry. I don't think this is water.
Yeah, so I think also not think this is not water. But what is the
No.
reason? This any type of wetland or other things?
Yes. Maybe type of soil.
So
Maybe petroleum.
petroleum.
Maybe. But it doesn't water. You will not found.
It's a lot of region look like this. You can see this region is also here. Look like a black color. Black color when I use this types of pen combination, black color it's identify the water body or wetland like this.
No, Saudi Arabia has a very little water areas.
What's the
Very,
place
very
of
little.
this? I think it's the Haram Sharif, yeah.
Yes, haram. You may be found here, Zamzam.
There's a lot of field of area. Okay. Third, the what are
You may go to the Jeddah or the Red Sea.
go to the near the Red Sea.
Yes, this is the water body.
What is this?
I don't know. But it doesn't water body also.
So we are getting this these types of black color. We get the as a water, and then try to make the and see what the problem. Then we can get a lot of water body. When I use this, consider this black color as a water pixel value, then I can get a lot of water body. You can see there's a lot of black uh, color look like area in this region. So it's also better. You also somehow you also try to find out this region, this types of black region. What's the identify? It can be water body or it can be other types of wetland. So you also try to find out the solution. Okay, then you can also get the better LULC map. Otherwise, it's also when I get the pixel value as a water body in this coding, then it automatically get all of the black color as a water body. But there is not much water body in the Saudi Arabia. But when I use this, it's showing a lot of water body in the region. Okay? So
Yes.
you also try to find out this type of color, what's its mean. So it's the wetland or it is the petroleum or other things. You also try to find out, and then we also classify it easily, no problem. So it's very crucial part for the taking the training point. If you are mistake anything, then you did not get the result properly. Your classification get the wrong result. Okay, so that's why we need to very carefully get this result. Okay, so I also send you this code link. Okay, so you also try to get the read the code link, and then you also try to find out what types of feature in here. Okay, so I also send you this code link today, and then we also try to make the land use land cover classification map for this region of this Al Modina region. Okay, so I also send you this code link, and you also try to find out what's the yellow color look like. You can see this type of place. You can see this type of place as a black color. What's it will be identified. Okay, so you also try to find out this solution, and then we also take the training point for this place. Okay, then we can easily classify it. Otherwise, in this time when I work with this place, I get the totally wrong map. Okay, so
Can I
yeah,
classify depend on type of plant? If I have an article that talked about many types of plant like herbs, woody plant, and so on. Can I classify depend on them?
what I don't understand.
If I have an work on types of plants
Yeah,
like herb, wood, annual, and so on, can I classify depend on the type of plant?
yeah, we can also classify it. Yeah,
How?
it's also possible. Okay, so in this time, so you also contact this class tomorrow. In this time, I also send you this code link. Okay, and you also try to find out this what's the land, what's the type of this land. Then we also try to add the new training point, and if possible, you can also try to add this point. Suppose click to the new layer, and then simply click to here, and then you can simply put the name. The same process, feature collection. Put the property name is the class. Set the value for 3, then click the OK
Is
and take the training point.
the value is a fixed number or you put any number?
So in this time, I take the training point as the pixel value. Okay. Suppose water body, this is the another pixel value. For the build up, this is the another pixel value. For the vegetation, this is the another pixel value. Okay.
I
So
can't
different types of
understand.
feature has different types of pixel value.
you gain the value from what? From where? Sorry. The value that you write from 0, 1, 2.
Okay, so basically this is the sequence. Suppose I take the first time 0, all of the training
Just
point, all of the
just sequencing.
yeah. So
Just sequencing.
this sequence means that step by step. 0
Yes, yes.
is the first
Mm.
first classified.
It doesn't indicate any value in real time.
Basically, in this
Just
time you can see vegetation. I take the
sequencing.
vegetation total 33 point. Okay, 33 point. This 33 point is included total all of the value. This for this 33 point all of the value is the 0. Okay, 43 point of the build up area all of the value is 1. 54 all of the training point value is for 2. Then 3, like this all of the class you can put the value. All of the training point have a value. Okay,
Just numbering.
just a
Just
numbering.
numbering.
Yeah,
Step
yeah,
1, 2, 3,
yeah,
4,
yeah.
and
Just
so
a
on.
numbering. Yeah,
Yes.
yeah. Okay, just a numbering. So in this time you can see I can get the result in here, and I can if you want you can also use I don't understand what is the place look like this, and it's the river or other things I don't know much about this
Yeah.
place. So you also try to find out the feature, what is the feature look like this. You can also get the satellite images in here also. Okay, so you also try to find out this place and then take the training point for this place, then we can easily modify this. Okay, and today is the midnight in here already, 12 p.m. So you can also try to for your own self, then you also try to conduct this meeting the tomorrow inshallah, and try to complete the complete land use land cover classification map for this region. Okay, so you also try to find out the solution. It will be wetland or petroleum or other things region. You also try to find out. Okay, I also send you the code link today. Also send you the video link as soon as possible. So I hope you can easily got this. Okay.
I ask you a question, but you don't, sorry, but you don't reply. Can I classify depending on the type of plant?
Yeah, it's also possible. Yeah.
How?
So Lancet or Sentinel, both of images is the same process. Okay, but when you use the Lancet, we can get the result for the 30-meter resolution. When you use the when you use the Sentinel, we can get the result 12-meter resolution, and this is the high quality of satellite images. We can get the better resolution than Lancet. Okay, so I also try to show you the Lancet Sentinel both of images. It doesn't matter. So all of the process is the same. Okay, we can easily do it. Okay. Okay. So any question? Do you have any question? Hello, can you hear me? Hello. Hello.
Sorry,
Okay.
sorry.
Okay, so we also try to conduct this all of the rest of the part for the tomorrow. So you also try to find out the what is the feature in here. Okay, then it's also better. Otherwise, when you classify this map, we did get the something wrong in here. We easily make the different types of time series analysis. You can see for the we can get the satellite image for the year of 2020. All of them I can get, then classified all of the images for the different year. You can see for the 2020, 2015, 2010, 2005, 2000. Okay? So we are easily classified all of the images. We also make the change detection map. We are also calculated the area, all of the classes. Okay, so a lot of process we can easily handle using the Google Earth Engine platform very quickly and efficiently. You can see the 2000 we can get the lot of vegetation area. and when I find out, you can see for the 2000, get the lot of, it also decreases, it's also decreases, you can see also decrease the vegetation. Okay, so this is the process we are easily doing for the change detection map, as well as also make the different types of image collection. We are easily get the all of the accuracy. Okay, we are easily get all of the image accuracy, what's the accuracy map. Okay, we can easily classify it. So a lot of things we can easily handle, but our main target is that we need to take the training point very carefully, otherwise we get the result, we did not get the proper result. You can see we need the training point very properly, otherwise our result is not good. Okay, so you also, this it's not only for the Modena, so any region, first of all you need to have the better idea about this place. All of the feature you have already know, it's the water body, it is the build-up area, it's the vegetation, it's the mountain, it's the fallow land. Okay, you have to need already have the idea about this place, then you can easily get the training point and make the result, make the LULC map. Okay.
Yes.
Okay. Okay, so today is no more. We also try to conduct this class for the next day, inshallah. And you also try to find out the solution about this place. What is this? Okay, it's the wetland or other things or the. So you can also get the result. Also satellite image. It's also available. Okay, we can get the satellite image, and you will try to find out this solution about this. And okay, and it's possible you also try to find out the water body in this region. Okay, and I don't know where the water body is available or not, because there is the very little mass of water in here. So then we also classified the vegetation, build-up area, barren land, and water body. And you have some other features. Suppose you want to also classify the mountain. You from this place you also try to classify all of the mountain. Okay, mountain means that high level area. Okay, so from the sea level it's the also high, some highland. So we can easily classify
Yes.
the mountain, no problem for this. We are also classified the lowland. It's also possible, no problem. Okay, so because we can easily identify the mountain or highland, lowland, we can easily identify in this region. Okay, so in this time you also try to find out this training point, then we also try classify this map very easily. Okay, and I also send you all of the code link, so you also practice. Okay, I also send you the practice video recorded classes. Okay.
Okay.
Okay. Okay, so today is no more, here the already midnight. So okay, so inshallah tomorrow we also again meet. Okay.
Okay, but please send me the recorded video.
Okay, I send you all of the things, no problem.
Okay, thank you.
Okay, thank you. Okay, okay, bye. Allah Hafiz.